there are two special right triangles, and they have to do with certain triangles that have specific angle measures and how the measures of their three sides relate. One reason I make sure to include this, it is in our textbook, so it's not like I'm pulling it out of nowhere, but the questions about these types of triangles do appear on the SAT. And it's questions that lots of people miss, but it's not because it's terribly difficult. It's more so because it's just not covered very much, at least in my experience in the three schools I've taught in. So let's look at them here, and I'll try to make it clear how these are related. So the first special triangle is the 45, 45, 90. So this is a triangle that has one right angle, right here at the 90, and then two congruent angles, 45 degrees. Its two legs, that's the sides that are not the hypotenuse, its two legs are always congruent. That's why we see both an x and an x here. X equals x. The hypotenuse is always the square root of 2 times bigger than his legs. So if you knew the leg was 7, then the hypotenuse is 7 times the square root of 2. Triangle DEF is a 45, 45, 90 triangle. Find the value of x. So one important thing you need to make sure you remember is the difference between the legs and the hypotenuse. The hypotenuse is this one right here. I'm not marking it congruent, I'm just trying to show you this is what I'm talking about. This is the hypotenuse, because it's the side that is opposite the 90-degree angle, the right angle. So these two sides are the legs. And what we just learned is that the legs are always congruent. So that means if this side is 3 inches, this side is also 3 inches. So when you're moving from leg to leg, you know they are congruent. In the 45, 45, 90 triangle, the legs are always congruent. Okay. Triangle DEF is a 45, 45, 90 triangle. Find the length of the hypotenuse of DEF. So we're trying to figure out this value over here, because the hypotenuse is the side opposite the right angle. So look back to what we said right here. The hypotenuse is always the square root of 2 times bigger than his legs. So they show us the legs are 9 meters. So the hypotenuse is 9 times the square root of 2 meters. So to move from the leg to the hypotenuse, you have to multiply by the square root of 2. The reason I put these sentences after each example is I want to try to help you have a guide for when, okay, this is what I have, this is what I need, how do I get there? So if you have the leg and you need the hypotenuse, multiply the leg length by the square root of 2. So let's go ahead and talk about over here what we've already confirmed. The two legs are congruent. If I want to move from the leg to the hypotenuse, I need to multiply by the square root of 2. Now there's one more transition or relationship we got to talk about, because we've said what do I do to go from leg to leg? They're congruent. What do I do to go from leg to hypotenuse? I multiply by the square root of 2. So this last one says, okay, what do I do if I need to move from the hypotenuse to the leg? So let's go back and look at this. So to go from the leg to the hypotenuse, I have to multiply by the square root of 2. So if I want to go from the hypotenuse to the leg, I'll have to do the opposite. From here to here, we multiply by the square root of 2. So to go backwards, we got to do the opposite and divide by the square root of 2. So if we start with the hypotenuse, well, let me try to illustrate this. So if we start with the hypotenuse, that's the one that's square root of 2x. Square root of 2 times x. If we divide that by the square root of 2, then they cancel out, giving us just x, which is what we want for the leg. So if you have the hypotenuse and you need to find the leg, you divide by the square root of 2. One thing that may help you remember this, one of the definitions or one of the qualities of the hypotenuse is it's the longest side in the triangle. So if you're moving from the longest side to a different side, that must mean you're getting smaller. And in general, the way things get smaller is by dividing, not by multiplying. So the legs here are 7 divided by the square root of 2. And because it is a 45, 45, and 90 triangle, we know the legs are congruent, so 7 divided by the square root of 2 is also what goes there. Now, this is the other kind of special triangle. It's the 30, 60, 90. So both of these are right triangles. The other one has a 45 and 45. This one has a 30 and a 60, as the other do. Now, because none of its angles are congruent, it's also true that none of its sides are congruent. So we have 3 different relationships here. We just had 2 different relationships with the 45, 45, 90 because it was a leg and a hypotenuse. But now we've got the hypotenuse, the side opposite the 30-degree angle, and the side opposite the 60-degree angle. The side opposite the 30-degree angle, because you can see it's the x, that's the one that's easiest to start with. So if they don't give that one to you, that is the one we'll try to find first. Now the hypotenuse, if you look at the relationship between the hypotenuse and the side opposite 30, the hypotenuse is twice as large, it's 2 times as large as the side opposite the 30-degree angle. On the 45, 45, 90, we had 2 legs that were congruent. Here we have a shorter leg opposite the 30 degrees and a longer leg opposite the 60 degrees. So the longer leg, you can see right here, it is square root of 3 times bigger than the shorter leg, which is the side opposite 30 degrees. So we've got to work through all of these relationships. So first up, let's say they give us the side we like best. That's the side opposite 30 degrees. It says find the 2 missing side measurements. Well, let's try to find the hypotenuse first. You don't have to do that. This is what I'm choosing. To find the hypotenuse, we go back right here. Since we're starting with the side opposite 30 degrees, these 2 statements are right in line. The hypotenuse is twice as large as that size. So this one's 5 feet. The hypotenuse is twice that large, which makes it 10 feet. The longer leg, the one opposite the 60 degrees, is the square root of 3 times that, so it's 5 times the square root of 3 feet. So to go from the 30 to the hypotenuse, we multiply by 2. To go from the 30 degree side to the 60 degree side, we multiply by the square root of 3. So let's mark that up here. So to go from here to here, we multiply by 2. To go from here to here, we multiply by the square root of 3. So to find the hypotenuse, multiply the 30 degree side by 2. To find the 60 degree side, multiply the 30 degree side by the square root of 3. So again, the reason I have these sentences, the reason I have this picture, is so that when you're working on these, you should have this with you. You should say, okay, what did they give me? If they gave you this to start with, follow this pattern. If they give you something different to start with, find the pattern it matches. So here, they gave us the hypotenuse first. So if the problem gives you the hypotenuse, find the 30 degree side first, because this is the side that's easiest to work from. So we're going from the hypotenuse to the side opposite 30. So if you look here, the hypotenuse to the side opposite 30 degrees, we're moving backwards, so instead of multiplying by 2, we will divide by 2. So here we need to divide this by 2. 12 divided by 2 is 6 centimeters for the side opposite 30. So we will divide the hypotenuse by 2. Now that we have the side opposite 30, we'll use the same method we used before and say, okay, to go from the 30 degree side to the 60 degree side, we'll multiply by the square root of 3. So 6 times the square root of 3 is the measurement of the 60 degree side. So we've looked at what to do if they give us the side opposite the 30 degrees. We've looked at what to do if they give us the hypotenuse. So the last possibility is that they give us the side opposite the 60 degree angle. So you can see the 60 degree angle right here. Opposite that is the 8-inch side. Like I've said, the 30 degree side is what we want to treat as our base, what we want to go to. If they don't give us that, find it first. So to move from the 60 degree side to the 30 degree side, we'll need to divide by the square root of 3. That'll make this 8 divided by the square root of 3. So I want to go back to where we were over here to make sure this makes sense. To go from the 30 side to the 60 side, as we already said, we multiply by the square root of 3. So to move backwards from the 60 side to the 30 side, we will divide by the square root of 3. So that's how we go from 8 to 8 divided by the square root of 3. So we'll find the 30 degree side first by dividing the 60 degree side by the square root of 3. Then we'll find the hypotenuse by multiplying by multiplying this side by 2. If you look back here, to go from the 30 side to the hypotenuse, we multiply by 2. So I multiply this by 2, we get 8 over square root of 3 times 2. We get 16 over the square root of 3. So I encourage you, as you're working through this, use this page as a reference. First, check and see what kind of special triangle it is. Then, see what they gave you. Did they give you a leg? Did they give you a hypotenuse? Then use the guidelines here to tell you what to do to get what you're looking for. With problem solving, it's important to say, okay, what do I already have? What do I need to find? And how do I get there? And this sheet should help you see just that.